Hello everyone and welcome back to the channel. Today we are going to discuss a very important interview topic and a very interesting one also, that is short polling. Short polling is one of the most fundamental techniques used to simulate real-time communication between a client and a server. In this video we will explore how short polling works. We will write the code using a real-world API and apply short polling to fetch real-time data. We will look at the pros and cons of short polling, and based on the pros and cons, we will determine if short polling is a good choice in a particular scenario. This is a very common interview question and it is especially important for system design interviews. But before we jump straight into short polling, let's first understand why we even need it. What problem does short polling solve? And more broadly, what do all real time data transfer techniques like short polling, long polling, server sent events, and WebSockets? What is the problem that all these four techniques try to solve? It all comes down to one fundamental limitation of the web, and that is the HTTP protocol. HTTP is the foundation of the modern web. In its traditional request response model, a client sends a HTTP request to the server and the server responds back with a HTTP response, right? Now, this model has two important characteristics. The first one is this protocol is stateless. So every request is independent. The server does not remember any state of the previous requests, right? So the server does not remember any state information regarding a particular client. So when a client reaches out to the server always treats that particular interaction as a unique one and it doesn't remember anything about the past interactions with the same client. The HTTP protocol being stateless is for a variety of reasons, and the most important ones are scalability and performance optimization. The second property of the HTTP protocol is that it is client initiated. So the client has to always start the communication. The server cannot push data to the client on its own. It has to be first requested upon by the client. Because of these two properties, real time communication becomes a challenge. The client just cannot stay connected and keep receiving data whenever the server has something. This is exactly why techniques like short polling, long polling, WebSockets, and server sent events exist to work around these limitations and enable real time data transfer. So, without these techniques, if the server has some amount of data that it needs to transfer to the clients, it cannot, because firstly, it doesn't remember any state of the client, so it just cannot reach out to the client. And secondly, the protocol itself is client initiated. So, the server can only respond to any request, but it cannot initiate any request from its side, right? So, the client initiated nature of the HTTP protocol combined with the statelessness of it makes real time data transfer difficult, and all the four techniques here try to solve this problem. Short polling is one of these four techniques, and in this video, we will be focusing on it. So, to summarize the problem that these techniques try to solve, how do you get new data from the server as soon as it becomes available, right? And the challenge here is that the server cannot initiate contact. The answer is to have the client constantly reach out to the server for updates. All of the four techniques work in a different way, but the basic idea is that the client will constantly reach out to the server and try to see if there is any update for them. All right, so I hope that the need for short polling is clear at this point. Let's now try to understand how it works. So, the basic idea of short polling is very simple. Clients will make repeated requests to the server and the server will respond back. These repeated requests will have some fixed interval between them, and that is of course configurable, but this is the basic idea: repeated request with fixed interval between them. To elaborate further, we can divide the whole process into four steps. The first step is the client sends a request to the server. That is step number 1. The second step is that the server will respond back with some data. The third step is that the client will wait for some time, and finally it will repeat the same process again. So it will again make a request, it will get the response, wait for some time, and repeat the same. So anytime if the data gets updated in between two consecutive requests, the next request should get the new data. So that is the basic idea. Anytime there is a change of data on the server side, the client will fetch that data in the next request. Now let's try to get some hands-on experience and let's try to implement short polling with a real-world API so that we can visually see how short polling helps us retrieve real-time data from the server. So in this demo of short polling, we will be utilizing this particular API endpoint from CoinDesk that provides the latest Bitcoin value in US dollars. So as you can see from the response here, so we get the latest calculated value of the index, which in our case is Bitcoin. And this is the particular value that we will be logging to the console to see how we can get real-time data using short polling. One thing to remember is that we won't be requiring any API key. You can directly hit this particular URL endpoint, and that's what we will do in our code. So this is a very simple JavaScript code that I've written. So this is the API URL that we just looked at, and this particular function will simply return the current time in this particular format. This is important because we would like to see which request was made at what time and what is the response that we received. The most important function is this simple asynchronous function called short polling. We basically use fetch to make an API request to this particular URL. We get the data and we display the current time followed by the value of Bitcoin. So this is a very simple function. This function will make a API call, and that is not the hero of this code. The most important function here is set interval. Set interval in JavaScript will take a function and it will call that function with a time interval in between. So in our case, we are trying to make this particular API call, get the Bitcoin data, and we will do that for every 2 seconds or 2000 milliseconds, right? So as we have seen, this is exactly what short polling does. We make repeated API calls with a certain delay and we try to fetch the data from the server. Let's try to run this file and see how we are able to get the value of Bitcoin in a near real time. So you can see that we are fetching the value of Bitcoin every 2 seconds. Initially, the gap is only 1 second because there are certain overheads like DNS resolution that needs to be done. And apart from that, you can see that all the other calls are being made at a time duration of 2 seconds, right? And we are trying to get the data and the data is clearly changing. Right now, we are simply logging it onto the console. You could use this data and render into your HTML or log it onto a file system. That's up to us. So this was a simple demo on how you can use short polling and try to get your latest data from the server and consume that data. Let us now understand the advantages of short polling. The first advantage is that it is very simple to implement. It could be easily implemented with a very few lines of code using standard HTTP requests, right? And we have done the same in the previous demo, so it is super simple to implement, and that is one of the advantage. The second advantage is that it is compatible with almost all browsers, proxies, and firewalls. Short polling has been around for quite some time, and that has resulted in very great compatibility with a lot of browsers, proxies, and firewalls. The third advantage is the control that short polling provides. So the client maintains complete control over the polling frequency. So the polling frequency is the number of requests that you make in a unit time. So the client maintains complete control over the total number of requests that they make in a unit time. So if the client wants to make 100 requests per minute, they could do that, or they could do 50 requests per minute or 20 requests per minute. And the client maintains complete control over this particular number, and it could be configurable based on the requirement. So control is one of the advantage of short polling. Let us now understand the disadvantages of short polling. The main disadvantage, which is a deal breaker for many of the modern applications, is the high latency that we have when we use short polling. And the reason is because updates are only received at the next poll interval. What do we mean by that? Let us assume that you made a request to the server, you got back the response, and just as the server sends back the response, the data got updated. All right. So to get this updated data, you have to wait until you make the request again. So the entire time in between becomes a part of your latency. So you don't get the data as soon as it is available on the server, but rather you get it when you request for it the next time, right? And the gap in between when the server gets the data and when you make the request, that becomes your latency. And in applications which require very low latency, something like social media applications or chat applications or trading applications, for such applications, it might not be acceptable to have high latency, right? So that is one of the major disadvantage of short polling. The second disadvantage of short polling is the increased server load and resource utilization. There are many repetitive connections and disconnections. As you can see from this illustration over here, we make several different requests within a unit time, and all of these requests will add stress on the server, and it will occupy computational resources like CPU. It will also take up your network bandwidth. So since you make multiple requests in a unit time, right, for example 100 requests per minute, all these 100 requests will consume resources and it will lead to increased server load. This becomes important especially when the data on the server is not updated very frequently, right? So all those 100 requests might return the same data, but you still end up making 100 requests, right? So that is the reason why you have increased server load, and there are some applications where server load has to be kept low and you cannot just make a lot of requests in a unit time. All right, so we looked at the advantages, we looked at the disadvantages, and now we should be able to determine if for a particular scenario short polling is to be used or not. The first thing is low latency. We had seen that short polling does not provide low latency, so it should be only used when low latency is not critical. All right. The second one is update frequency is low to moderate. If the data gets updated very frequently, then short polling will result in high latency, and hence it should only be used when the update frequency of data is low to moderate. Also, short polling becomes a good choice when the implementation simplicity is really important. When the development team needs something that is quick and a simple solution, and it does not want to use any middleware or any other complex techniques, then short polling becomes a good choice. The final reason why you should be using short polling is when you're working on legacy or restricted environments. As we had seen, short polling has very good compatibility, right? So it should easily be compatible with legacy systems which run on old infrastructure, and they might not support other techniques like WebSockets. So in such a scenario, you should prefer short polling over other techniques. All right, so that was a very comprehensive understanding of short polling. In the next videos, we will be taking a look at long polling, followed by server sent events and WebSockets. So stay tuned for these videos and download your notes from the description. Thank you.